Okay, thank you. First off, I'm really excited to be here, and I'm also a little shocked that they let me have both coffee and a microphone. For those who know me, that's really kind of a deadly combination, but I'll try and be good. As it says in the abstract for this, it was kind of an unusual situation. The last day of finals, the fall semester, my chairman comes to me and he says that so-and-so's got to go on emergency medical leave and wants to know if I'll take over his advanced calculus class for him. At Slippery Rock, it's a year-long sequence, so I'd be basically hopping in mid-course, and given a chance to do real analysis, I, of course, said yes, whatever it takes. That said, this is also a really good idea for people who are interested in IBL, but kind of more want to dip a toe in before jumping into trying a full Moore method course. Now, the students who are used to lecture, graded homework, exams, the typical structure of a course, I had been spending part of the year developing a Moore method course for the next year when it was supposed to be my turn in the rotation for this class. So I didn't want to go backwards. I wanted to at least incorporate some of the Moore method things that I'd been working on. The students had a book, though, that they had paid for and had been using. And I could just imagine the screams if I said, okay, that book you just paid $100 for, well, $150 for, we're now going to ignore for the second semester. There was a thing, though. Not only did I not want the book, but it was really, really a bad book. It was even worse than I didn't want one. But I really thought, it's kind of unfair to them, so I want to keep the book involved. The students had not been graded in style or how they could present things or their ability to think on their feet, which, of course, is one of the things that happens in a course like this because they're being asked questions as they present stuff. And basically, meh. I mean, that's about all I can say, is, yeah, they hadn't been graded on it, but they'll get used to it. From the syllabus. Certain problems will be given out to the class for the purpose of presentation on Fridays. Students are to share their solutions with classmates at that time. Students are not allowed to discuss these problems with other members of the class, tutors, or anyone except the instructor. Students are not to use outside references, and this means that students are not allowed to access internet resources or use other textbooks for help. If you have questions, then I'm the person you're supposed to come to for your questions. Some of the problems. I wanted to extend what they were looking at. Some of the things, of course, having the book in front of them, I couldn't just say, here's the definition of derivative. A function f from R to R has a left or right derivative at C, provided that the left or right limits exist. So this is the extension of what's in the book. This is the problem. Give an example of a continuous function which is not differentiable at every point, but both the left and right derivatives exist at every point. Another extension of a current topic, if AN is a divergent series of positive numbers, then can I get a divergent series where all the numbers in that second divergent series is smaller than its corresponding number in the first one? That is there such a thing as a smallest divergent series? Give you all a second to absorb that. I also wanted to introduce them to new topics. One of the things that students have said to me before, and it really drives me bonkers, is that old, it's all known because it's all in a book. Since it's in this book, everything about advanced calculus or real analysis or anything is already known. So new topics. F is symmetrically continuous at C, provided the limit as h goes to 0 from the right of f of c plus h minus f of c minus h is 0. So a new topic here, symmetric continuity. So prove that if a function is continuous at C, then it also has to be symmetrically continuous there. Another new topic, one of my favorite things, Cauchy's functional equation. As it says down at the bottom there in the footnote, f from R to R such that f of x plus y equals f of x plus f of y. I've also heard that referred to as a freshman's dream. That f of negative x is the negative of f of x. Hidden topics. One question that people do ask me about this, how do you know that they're not going to look things up in a book? And the answer is, of course, you lie to them. So I have this new thing called M size of a set, which you and I, of course, would refer to as measure. But if they want to Google up M size, let's just see what they'll get. So show that for a set of rational numbers that the M size is 0. And one thing I'll add about something like this, at least at Slippery Rock, measure is not something you're going to talk about with undergraduates. Our advanced calc course doesn't get near measure usually. So at the end of the semester, when I pointed out, you all were cruising on some problems that had to be at graduate level. I really used that as something to pump them up a bit. You are better than you think you are. Student reactions. In the beginning, things were rough. The students had previously not been required to write formal proofs. I was a little shocked at my colleague for this, but he would accept his proof something that I would consider badly written scratch work. If there was an epsilon and a delta in there somewhere, then that was proof enough, and I'm a lot more formal than that. Despite many of them majoring in secondary ed math, they did not want to get up and talk. The attitude seems to be, I can get up in a classroom of high school students because I know they're not smart. But if I get up in front of my peers and in front of a professor, they're going to know when I'm saying something wrong. And so that involved a little bit of environment change. This is not combative. I'm not trying to get you up there so that we can laugh at what you can and cannot do, but just to kind of get you better at this. It's probably a little better for them than their public speaking course at the university. And finally, criticism was a problem. I can remember a few people in class pretty much being reduced to tears by being told that, no, that's not exactly the right example, or you're reading the definition wrong. That bit of frustration because they worked so hard on something that was just wrong. So that's something that took some learning on the fly for me. How to address these students so that they don't get too upset over the fact that you are telling them they're wrong and this is going on in public. My reaction. Are students going to rebel because they previously had lecture and homework and now I'm throwing in this extra thing? And again, this is kind of for those who know me, not in my class. For those who remember a couple of years ago, I have the dad voice. And you're not going to rebel in my class. Perpetual grading. I was warned about this. You're grading all the time. They're handing stuff in, and I'm saying, well, this is worth, 3 out of 10. Hand it back. They'd hand it back in a day later. All right, well, now it's a little better. Now it's a 5 out of 10. There's a lot of grading going on. And I was told that. The perpetual office hours, I was not told about. That took me by surprise, so I don't want to take you by surprise. Consider yourselves warned. I had students hanging out all the time, and the rule basically was if the door's shut, don't knock. But if the door's open, come on in. One thing that I did have trouble with, and whoever knows the answer to this, help me out here. Person comes in, hands me their homework. I'm looking at a page. He wants to make sure everything's right. I say, well, you're good up to here, and I point out where the first mistake is. He goes outside my office. He corrects that first mistake. 2 minutes later, he's back in the office. How is it now? And this would go on for an hour. So if anybody's got a polite way to cut somebody off at the knees, let me know. Student comments. Now, I'm tenured, I'm promoted. If I don't have to do student comments, I didn't even think about doing student comments. So they didn't do it at the end of the year. That was kind of my bad. But when I thought about putting this together in a talk format, I said, well, I really would like to know. So a year later, I contacted the students in the class and I asked them some questions. So this isn't perfect because not everybody replied, but I asked questions such as, did you feel that you learned more because of Fridays? And this is from an email that I got back. I did learn more because peer evaluation was integrated into solving those math problems. On Mondays and Fridays, we just sat there and took notes and was given your insight. But on Fridays, we were able to see how the beginners were able to approach problems. Did it improve your experiences or detract from it? I love this one. I believe that it only improved my experience. Basically, that whole semester was an experience. I not only learned about mathematics, but rather I learned what I was truly capable of. Even though I only got a C for the course, I still feel that C was the best damn C I have ever earned. Did it help in future classes? Before taking a proof course, I would never have thought that it would make me a better student. However, that specific class has taught me how to think and look at problems in a logical manner. Maybe it was a combination of all the math courses I've taken, I don't know. But what I do know is that Math 314 class truly helped me, and being that I completed it, I feel much better as a person. To be completely honest, I was not too happy whenever I found out that we were going to be presenting every Friday through our analysis class. Now, after it's all said and done, I have a bit of a different opinion. Presenting in front of the class was actually not too bad. I can honestly say that I would not want to learn higher level math in a different way. The semi-more method taught me much more than the analysis material. It taught me the mathematical definition of hard work, dedication, and pride. Okay, my pithy ending. For those who can't read that, that's his new slide with an ending something something. What do I want to say about this? Was it a great way to do the course? I really had a good time with it. I think they learned a lot with it, but I did not continue doing it because my plan was to go to full more method when it was my turn in the rotation. So I can't stand here and say, well, I tried it once and now every year this is how I do things and it just gets better and better. I'm going to assume that it would get better and better because it worked so well the first time. But I just can't say for sure. It took a lot of effort. It does help that I also publish in Real Analysis. But one of the things about this, since they did have a book, is I can't give them a problem that says, prove the mean value theorem. That's in their book. What I can do is define a symmetric derivative and say, prove the symmetric version of the mean value theorem, or decide what the symmetric version would say and then prove it. But that does take a lot of extra work to go beyond the book. So do be prepared for that. I've given you a small taste of the problems that I used. It never ever occurred to me to make handouts, but I did bring a couple of copies of the entire problem set. I think there were 90 some odd problems altogether. So if you'd like to look at that, let me know. If you'd like a copy of your own, you all have my email address. I'm more than happy to send you the PDF. Last thing that I do want to slip in here, what about grading for something like this? There were, well, 2.5 types of grades, maybe. There was the grade on your presentation. And in typical style, it was who has number 18, who has number 19, who has number 20, that kind of thing. There we go. So that was how I got people up at the board. If nobody had anything, then I had my notes about who had not presented lately. Aside from presenting at the board, there was the written version that was turned in. If problem number 15 was turned in before somebody had presented it, you could get up to 10 points. If problem number 15 was turned in after the presentation, then the most you could get was 5 points. I did not do this alone. Jackie Jensen helped me, my mentor, if you will. And I kept saying, how am I supposed to grade this? How am I supposed to grade this? What am I supposed to do with these numbers at the end? And she kept saying, don't worry, they're going to self-separate. And my God, she was right. If different people are turning in different problems, how do you decide what's an A's worth of score, what's a B's worth? But it really, once I totaled everything up, it was perfectly clear and fit in absolutely fine. So thank you, and are there any questions?
I think it is. Okay, so my suggestion is that I respectfully explain to my students that I expect them to self-evaluate, and I will not pre-grade something for them. I say, if you have a question about something that you did, I will be glad to address that question. So I don't read it, find a mistake, and point it out.
Okay.
But, so I'm kind of asking them to say, well, you know, I felt a little nervous about this part. Glad to do it. If they're stuck, I'm glad to help them find a way to get unstuck. But I don't let them do that, and it simply eliminates the problem that you were talking about to do that.
Okay.
I think.
You mentioned that you did regrading, so you would have 5, and then they got a 7 out of 10. Did you find that a lot of students turned in crap before the presentation so that they could earn up to a possible 10, or was there a limit on how much they could earn back for rewrites?
No, I found most people really turned in an honest attempt at the problem. You know, maybe that was a little bit of fear, like, you know, I'm going to say in class, well, you know, you showed me something the other day, why don't you put it up? And so they want to make sure they have something good.
Like Carol, I have a suggestion for your problem. I don't read in front of my students. This is something I got from Ed Berger when I took a class from him as an undergrad. He was irritated with us for other reasons, but my students figure out pretty quickly that if they want that kind of help, the thing they have to do is come in and pick up a marker and start trying to prove something on the board. So my office is exactly like the classroom, that if they want to have a community discussion about their ideas, they have to start presenting. And pretty soon they just do that without asking. And so that stops exactly that phenomenon.
Other than writing proofs and making presentations, is there any other component of the course grade? I mean, for example, do they take exams, quizzes, or?
Yeah, I don't do quizzes, but there were 3 hour-long exams during the semester and a final. One last question?
Hi. I also do a lot of work with student presentations in class, and I'm curious 2 things. 1, do they know ahead of time which one they're presenting? And 2, what sorts of presentation technology do they use? Are they writing on a whiteboard, or is it pre-prepared?
They're writing on the whiteboard in front of the room. They don't really know ahead of time. As I said, I'll go through, you know, where we stopped last. So anyway, I have number 14, number 15, number 16. And you can have a beautiful number 16, but somebody's got their hand up first, then you don't get to present it. And as I said, I will work to make sure that people who are starting to lag behind a little bit don't just stop presenting. So that can happen. And I worked a couple of passes into the semester. You know, if I call on you and you don't have anything, you know, you can pass twice. But if I call on you this Friday and you say I'm passing, then you're the first name out of the chute next Friday and you need to have something. Okay, I'm out of time, so thank you.